Hi, thanks for joining our session today on IIoT technologies and how it can help lead to engaged, optimized, and profitable customer relationships. I'm Stephen Steen. I'm the Vice President of Industrial IoT with Poseidon Systems. And a little bit about us. We're a leading innovator in developing and manufacturing real-time condition monitoring solutions and really focused around condition-based maintenance. But really, a lot of our technologies and our core competencies around oil sensors and oil sensing technology and how you integrate that back into the cloud and run diagnostics, providing a real full end-to-end solution for our customers. And so that really allows a lot of our customers to use this information to optimize maintenance practices and avoid unscheduled downtime and other things like that. We'll talk a little bit more about that today. For some of you, IoT might be a little bit new and might not have a lot of background around that, but really as a summary, it's really billions of industrial devices connected to a network sharing data. So it can be anything from a temperature sensor to other things like that within the industrial realm, connected back, sharing that data, and then obviously from there allowing you to garner some sort of value from it. When we kind of compare that regular IoT to IIoT, the industrial IoT, a lot of people get confused, and so one of the differences, the real difference, is the IoT is consumer focused. So you might be thinking more of house automation or smartwatches or other things like that. But really in the industrial IoT space, we're focused a bit more on cost savings, efficiency of industrial equipment. So really not so much for fun, but really to help drive efficiency and improvements in cost savings within our industrial pieces of equipment. There's a lot of myths around IIoT. Myth number one is that it's new. It's not really new at all. We've had some sort of SCADA or other things around since the advent of the PLC a long time ago. And so ever since that point in time, we've been doing IIoT. Really, the change has really happened as technology has advanced and it's been cheaper and easier to connect these different sensors and devices back to some sort of data collection standpoint where you could aggregate and use that data. So the innovation and the change in the near recent term was more about the innovations of using and scaling the technology a little bit farther. And the other myth that a lot of people have is that IIoT is hard to implement. Really, you're probably already doing some form of it. So to keep that in mind, the question then becomes, what is beyond that you could be doing to engage and improve and expand what you're doing today is really the question, as opposed to whether or not you can or are doing that today. And so there's a lot of common words and definitions that people get confused about or don't know a lot about. Gateway edge device is one that stands out. And really, that's just a piece of hardware that receives and transmits data. It's how the sensors and the technology pulls that data and pushes it back from somewhere, within the plant or the facility or where that's located back to some sort of access to the network. Telematics goes a little bit further. It's really more focused around long-range communication, used a lot on mobile piece of equipment and that sort of thing. So a little bit beyond the gateway edge device, telematics is really thinking or focused on long-range communication. PLC, which I noted earlier, programmable logic controller, it's really just a ruggedized computer for automation, a little bit more reliable than the blue screen of death from your Windows PC or something else from the other solutions that are out there. It's really meant to be on all the time, working consistently. Big data, another term that's used quite a lot. Really, it's just a large pool of data pulled together from many sources. So it could be operational data from one source, it could be maintenance data from the other. It's really just the idea, the concept of pulling all those together into one location. Cloud computing, another one that you hear quite often. That's just remote servers used for storing and processing data. So it's really a non-local way of storing the data. Again, a lot of myth around that of what that is, but it's servers somewhere else in a remote location. Edge computing, hear that quite a lot as well. That is, instead of doing it more in the cloud, it'd be more of a local real-time processing of the data. Condition monitoring, also one words that I threw out earlier. Really, it's the process of monitoring indications of failures or breakdowns. So it's really starting to get the value creation from the hardware and the sensors that are installed. Digital twin, big one that's been around a while. And again, from a conceptual standpoint, it's just a virtual model of processes or a physical asset or something else like that, to kind of identify what should be happening with that and compare that to reality to see whether or not things are happening the way that they should, help you identify if there's any issues, or model what that process should look like. Machine learning and AI kind of go hand in hand. Machine learning is really a subset of AI. It's a methodology of automating the building of mathematical models. Lots of different approaches and things there. And then AI is a larger piece of that, which is a simulation of human intelligence in machines. So automating some processes or some sort of learning along the way to help with decision making and speeding that up. So with the concept of IoT, obviously there's a physical hardware architecture behind that. This is a really simplified version of that for those who'd be interested. At the very low level, you have the pieces of equipment where the sensors live. On those pieces of equipment or in that vicinity, you can have that gateway or edge device or PLC, which is that hardware layer that's collecting that. That's also where you would have some of the edge processing that I defined earlier, where you could do some localized intelligence and decision making. From that edge device, PLC, telematics, you're pushing that then up to the cloud. In some cases, it could be a local server as opposed to a cloud server, but that's really where you can store that data, or the big data would be located. And then on top of that, you have your analytics software alarming. And so that's really where the value creation, everything below that, outside of some sort of edge computing decision making, those are the necessary evils of just getting the data, pulling the data back, getting it to a location. Really, the value is created with the analytics software that's available. Some of that, again, is done in the cloud. Some of that's done on the edge or local. All of that fits within the paradigm of IoT. For lubrication suppliers, a lot of the value that can be helped created from this is, what does that data mean? How do you select the sensors? What sensors make sense? And what assets should these put on? Lubrication suppliers inherently understand the formulation. You can help recommend what is the useful life of those in the different applications. And so having that data kind of pulled back in a way to look at that is really valuable. And so as part of that value chain that's created for the different market players, again, using that same diagram, on the right-hand side, kind of another layer to this is the oil labs. So oil labs provide very useful information. We'll talk a little bit about that today as well, how that integrates with IoT. And so there's obviously value from getting information from the lubricant oil lab, putting that back into the big data location and storage. And then when it kind of comes down to that asset level, again, the question becomes, lubrication suppliers can really help us understand, again, understanding the formulation, the recommended useful life, and what can go wrong on that particular application, what sensors would make sense in that particular application to make sure you can identify a problem very, very early on or before it even starts. The other side, on the left-hand side of the diagram, the question becomes, what assets? Again, understanding that application, how that application is going to cause problems within the lubrication system or with the lubricant, also can help identify what's the most at-risk asset given the way that it's operating, what it's doing, and how that looks like, and flowing that back. So which assets should be monitored first, and kind of on down the line. And then once that data is pulled all the way back up into the software analytics providers, really understanding what that data means is a critical piece to this. So you really can't create the value unless you can understand what does the data itself mean. And once you've identified a problem, again, lubrication suppliers understand inherently a little bit more about what solutions could be applied to fix the problem. Should you bleed the oil out, change the oil, do a top off, etc. Maybe even switch to a different oil for that application, given the information that's pulled back through the IoT system itself. So there's a lot of value within IoT at a high level. It contributes mostly, the goal is to reduce the total cost of ownership. And the ways that it can do that is increase process efficiency. So having that data more real time helps you be a little bit more efficient in what that looks like, as opposed to having more manual processes with technicians or whatever, pulling samples more often. The improved quality, the repeatability with the sensors, quite nice in terms of making sure the data points you have are repeatable and consistent. Overall, providing a better service to the end customers by understanding the assets a lot better, which can reduce the total cost of ownership as well. Improving and helping with the troubleshoot of maintenance. So the sensors inherently and the data that's being collected should identify more challenges or issues earlier to do a lower cost of replacement or help troubleshooting what's going on, as opposed to kind of going into it blind. Improving the safety with having less interaction physically with the human to the machine, being able to do some of that diagnostics remotely, reducing the cost and downtime again by catching things earlier, coming up with better solutions so that you can reduce the downtime in the future. Increased productivity and reliability is a big piece of this because of that. And then really in the end, extending the equipment and lubricant life. So all the things above to help do that more efficiently all kind of bleed in to help reducing the total cost of ownership by extending the equipment and lubricant life itself. So I think everyone should be fairly familiar with lab technologies in general. An example on the right side of the slide is from one of our partners of the numerous different types of tests that are done from a lab sample, which is significantly more in depth than what we do in the IoT space. And so we're not really trying to replace lab analysis. We're trying to use lab analysis to help identify what the root cause is, to identify what's going on earlier, and supplement the value of what a IoT system can provide, because the lab utilizes over 150 different tests to provide accurate and repeatable direct measurements, so that you're going to get exact measurements of exact properties or contaminations or whatever that might be. And so instead of trying to replace that, which can't be done today, we're really trying to complement the lab analysis by identifying sensors and sensor technology that give us the information necessary to understand that there is something wrong, not necessarily in each case exactly what's wrong, and I'll have a couple examples to show from that. And so one example here would be kind of what would that system look like with real parts and components. On the left-hand side, you can see a series of different sensors that could be available. Those would be connected back through Wi-Fi, Bluetooth, wired connection, LoRaWAN. You can kind of list a whole bunch of different communication protocols to get those back to an edge device. The example of the black one is our edge device, and the one below that is a LoRa edge node for communication, which we can then use to communicate back through cellular or, again, wireless or wired connection to some sort of monitoring system. In our case, we use what we call Poseidon Live to do that monitoring. Again, as part of that system, where can lubrication suppliers provide that value? What sensors are needed? Again, it's a good discussion to have what really is going to provide value back based off of that lubricant in that application. And then two, when you do have that data back, what does it mean? What does it look like? How do you assess the goodness of what that data is telling you and what that looks like? So the question comes out, why IoT for lubricants specifically? So if we look at oil condition monitoring, what value does it add to that? If you look at the graph on the right-hand side, there's an example of very similar scenarios as the generic scenario, but we come in quite often where you just have offline lab analysis taken maybe once a month. So you take a sample on roughly what would be day one, and then the time off of that, finally after a couple days, depending on how that site operates, the sample's shipped. During that time, an issue begins to form within that piece of equipment and the lubricant. Oil sample is analyzed and understood, no issues detected because of when that oil sample was taken. But in that time of processing it, a lot of times a contaminant can come in, something can start to break down, and while you think the lubricant's going well, it's actually not because of when that issue began. Compared to using some sort of online condition monitoring, you can see at the bottom right, when that starts to degrade, the issue begins, you see that detection, you can take immediate investigation repair during that time because you know something's wrong. You may, again, not know exactly what's wrong until you do an oil analysis, but at least it allows you to rush and kind of get that moving so you can return that back to service before it causes continued damage to that piece of equipment. So what is that value? The value is that it's always on. So if there is some sort of failure or problem, you can know that there is something wrong depending on the sensor that's being used, which then allows you to do enabling your proactive maintenance, so you can catch those conditions before they cause damage, proactively fixing them. There's a repeatability with sensors that you don't get with a lot with some of the sampling. We can train technicians a lot, but still there's just small human errors that can come in there, as well as the inconsistency on how often those samples are taken. There's a lot of variability that come in there that you don't get with sensors that would be a lot more repeatable with the number of data points that are taken. From a safety perspective, again, you're reducing personnel near equipment, so inherently you're improving your safety. And then remote locations, less visitation, so you're reducing costs there. And then reducing dependency on lab analysis allows you to kind of optimize when you take those samples and use them more efficiently. Just some examples of online oil sensors, a wear debris sensor, which would be focused a little bit more on the debris coming off of bearing faults or gear faults or whatever else it is, identifying that there's some sort of early stage fault within the piece of equipment. That's more focused on the health of the asset itself. On the oil quality side of things, the bottom left-hand corner, that's going to be a little more focused on the health of the oil or lubricant itself. Lots of different sensor types here, water and oil, conductivity, impedance measurements, dielectric, etc. It's really looking for abnormal changes in oil condition. There are particle counters, which everyone should be familiar with as well, that gives you your ISO cleanliness, which is different than the wear debris. So you're looking at cleanliness of the oil on the bottom right versus the debris from a fault or failure on the upper left. And then you have other ancillary sort of connected breather type technologies, which are, again, preventative in terms of trying to keep, in this case, humidity and water out of your system. But now that there are connected smart breathers that give you a little bit more tracking of the life, the direction of the humidity, that sort of thing, allows you to kind of know the state of the lubrication system and all the components and how well they're operating to date. So I want to give you a couple of examples of how online sensing and lab analysis either go hand in hand, complement, or improve each other. So this is an example of roughly 140 industrial gearboxes. This is about 3 years worth of lab data, and we're really looking at a bunch of metrics that you typically would look at to see if there's an indicator of machine health. So ISO cleanliness would be one of those. The other one would be iron concentration within that sample. And if you think of the 4-ounce sample you're getting, you're not getting a lot of volume. You're not really getting a good representative sample. And in that, all the blue lines are amplitudes showing a proven healthy gearbox. There's no issues with it. And where they showed up on the lab analysis, all the red ones were known, proven, faulty gearboxes with issues. And you can see that there are just as many, if not more, known healthy assets above the warning level, and there are several failed gearboxes that never even reached above a normal lab warning or alarm level. And again, that's because of when you pull that data. If you look at the graph then on the upper right-hand corner, which shows you a real-time 24/7 monitoring using the wear debris sensor I showed you in the previous slide, you can see that through that sensor, we had a detection a couple years before it actually had a catastrophic failure, identifying that fault and letting it run over time. There were a handful of lab analysis taken over that time after we identified a fault, borescoped it, and each one of those had normal iron or ISO cleanliness values that were well within the norms of what you would expect to have. And if you look at the peakiness of the blue line in range 3, where it starts to really get to a high level of generation, you can see when you would take that sample will really play into it. Was that asset running when you took it? Was it kind of shut down and the particulate, the debris able to work its way out of the oil from the oil sample? Did the good oil sample taken at that time? A lot of variables go into that, but we have quite a bit of data showing in great detail, that the variability in detecting the health of the asset with lab samples is a hit or miss. Mostly, again, because of the repeatability compared to an online sensor, which you see here, which detected it fairly early and was able to operate it without having the piece of equipment fail through the end of life. Now when we start to take a look at how do different sensors play into each other, in one case we have a water and oil sensor as well as the wear debris sensor that we talked about previously. And so what's nice about this particular example is that the water ingress was the root cause of the problem, getting in there through a sort of leak or an oil change issue. And so when that water was actually put into the system, you can see that the red line at the bottom After the humidity railed all the way up to 100%, which you can see in the sensor, you can see the debris started to spike and be produced. And really, that was because of the water in the system causing damage to it. We were able to immediately alert and then have that shut down while the water was flushed out of the system. And you can see after that oil flush had been done, dehydrated, put back, the wear debris had worked its way down. And then over time, you're still kind of working the humidity out of the system. It kind of returned back to what you would normally expect to have in a industrial piece of equipment like this, a gearbox around 30% for this particular location. Had we not had online monitoring here, this would not have been caught. That damage to the gearbox would have continued to be done over the next couple weeks or months, depending on how long that would have happened before they would have had an oil sample come back with high water content. This is an example of using oil quality sensors to understand, again, the oil quality over time. So this sort of detection that there is, quote unquote, something wrong, not necessarily that we know what it is, but something has changed, there's wrong, and some sort of action should be taken. That orange line in the graph, you can see that there's this normal degradation, relatively linear through that until it gets to the orange section where it kind of accelerates that downward part, which would trigger an alarm in our system. So this was triggered. Immediately an oil sample was taken, pulled, and kind of rushed to get some information back while the asset was not running. Found that there was a large coolant leak within the system that was caught instantaneously. It was then taken in, gaskets changed before it caused quite a bit of damage to that gearbox, or sorry, to the diesel engine that was installed in. And once that was fixed, put back to service, you can see it returned back to kind of normal operation. And that was able to prevent a $500,000 engine rebuild had that not been caught. And from an oil lab analysis standpoint, they were roughly on a 1-month cycle, so they probably not would have caught this for another month or two, depending on how long it took to get the results back. This is a good example of showing just how different assets, again, operate differently from each other. These are two industrial gearboxes that are side by side in the same location. One of them was, these are all using the connected breather example that I showed you earlier. Each one of those is showing breather life 100% down to 0. And you can see on one particular gearbox, that gearbox was obviously having a water issue where the breather life was just being sucked down relatively quickly. They were replacing these roughly every 6 months based off of just a scheduled maintenance cycle. But the one gearbox had a connected breather last over 1.5 years, so almost 3 times as long, meaning they didn't have to replace that breather itself. And it only had gotten down to 50% in about 1.5 years, while the other gearbox was very quickly working through the breathers based off of that. And so they were able to look at the piece of equipment and identify that there was an issue with it, and try to get that back to normal operation. So what would an example system look like with actual sensors themselves and not diagrams? This is an example of what we call the Trident FQMS, the Fluid Quality Monitoring System. If you see in the left-hand side of the screen, it's basically a stainless steel Nemaphore enclosure with a wear debris sensor, a viscometer, the oil quality sensor, which also has a relative humidity element, direct measurement as well as temperature. And it's all pre-wired together to make it easier for installation. So there's 2 cables that get connected at the top of that box, and there's one inlet and one outlet of the box itself, so you have the lubricant flowing through that. On the right-hand side, you can see 2 example installations. One is on the outside of a haul truck, where the diesel engine is flowing through the box and then returning it back to the sump. And the other one, compressor, where you can see, again, same inlet, outlet, cables coming off back to the data logger inside of an electrical cabinet. So what's nice about this, and with an IoT in general, you want to make it easy to install. If you're just installing single sensors here or there, it's not a big deal. But if you're really looking at, and again, if lubrication suppliers identify that there's multiple different sensors needed, having kind of one package to install makes it easier to do it at a larger scale. And so once that box is connected, We, in our particular system, connect it back to an edge device called the AP2200, which is that black box that goes inside of a electrical cabinet, which can be used to feed that data back to the monitoring system itself. And again, where can lubrication suppliers help out quite a bit is what's actually needed. Is the 3 sensors within that box, the standard equipment, really necessary, or is it a subset of that? Or from an optional standpoint, from our standard, maybe it should include something else from the list. And so if you have a good IoT solution, you have multiple different sensors that you could integrate back into there based on the need of that particular equipment, as opposed to a one-size-fit-all that may have too many or too less sensors that don't tell you what you need to know, or collecting useless data. So there's a really big part for lubrication suppliers to play in identifying what that should be. And this is a good example of how that flows all the way back, having those boxes installed on haul trucks, feeding data back, getting live data, seeing that data back on a smartphone, a tablet, on your computer, wherever it may be, getting your alarms and your alerts so you can take action from a technician standpoint, as well as maybe an advisory role for lubrication suppliers back to the customers. On the right-hand side, an example of that data flowing back from a haul truck to the cloud, to a user's phone, looking for that coolant leak example that I told you earlier. On the left-hand side, a good example of a customer who is just changing their oil way too often. One of the particular sensors can see the break-in period of that oil. So as that oil is being broken in, kind of increases in impedance before it comes back down. This is an example of where they were basically changing the oil in a cycle that didn't even get to the break-in period, and so able to provide value in extending the useful life of that oil in that particular use by using the data that's been fed back through the system. A lot of questions come back beyond oil. What else is there? There's obviously not a lot you can do for inline monitoring or online monitoring of grease, because it just doesn't move. It doesn't flow anywhere. But you can get kind of closer to that. This is an example of a device that a technician could bring with them, or an O&M team could bring with them. Take a sample of the grease itself, drop it into the top of the device, and because it is able to be connected back into the IoT system itself, that data can flow then back through a phone, through Bluetooth, whatever it might be, into that data lake or big data system. So you can also bring in grease monitoring. So if there's a grease route that's being done, we have a lot of customers that have this device in one location. They do a grease round, bring them back, run it through the device, look for ferrous concentration. If for whatever reason the ferrous concentration is above a certain level, then they can go back and take action. They can flush the grease, whatever that might be. So while we may not be able to do online grease monitoring, we can, through some devices like this, start to do at least on-site sort of analysis and have that data, exact same data, flow back into the same system to track and monitor it over time as well. So where is the state of IoT adoption? Some of you may be surprised or not, but it is here. I mean, there's a lot of places and a lot of industries that have taken it on very quickly. There are some areas though that are behind, so it depends on where you're coming from. So online sensing in general technology, that is the norm. The question is what industry, what sensing technology, that really dictates the level of adoption. So in the oil condition IoT space, that is a bit of a laggard compared to some of the other sensors that have been out there for a while. For many reasons, the sensors do matter. So some people may see, all the sensors are the same. Really, some of the early sensors in the IoT space for oil conditioning monitoring have under-delivered the promises. So there are some newer sensor technologies out there that are finally unlocking those promises. And so those sort of improvements are helping speed up the adoption now that we can actually meet the value that's been promised. So again, from that, the value creation is improving. Data platforms are getting better. AI, machine learning are helping to improve the creation of that value from the data. One other big piece of this is cost is reducing. You obviously need a business case for it. From 5 years ago, I would say the average pricing of different systems stuff come down almost 50%, depending on what it is. So that helps the business cases quite a bit. Another big piece is having access to higher speed internet, whether it be remote access through cellular connection, being faster, having more wired internet access, etc. That's all been a lot, been improving the access to this. And as an example of that, over the past 5 years, we've installed over 7,000 oil-based IoT systems, and that number is growing. And within the next year, we expect that to double as well. The uptake is starting to swing in the right direction, and some of the early adopters are going to a pretty wide implementation here. But overall, I definitely would say, from a stage of adoption, most of the market is in between the education and the pilot phase, depending on where they're at. They're either learning about it because they used some of the old sensors in the past and didn't have good results, or are in the pilot phase trying to figure out whether or not the sensors meet the expectation. Can you create value from the data? A lot of the early adopters, though, they're already towards that fleet deployment space. So they're really thinking about what assets are the priority. Where do we kind of deploy these first, and then what else is new? The new sensors are coming out. How do we plug them into the system and increase that over time? I think there's a big piece to play with lubrication suppliers. I think you can accelerate the adoption of at least small deployment phases, kind of skipping the one-off pilots, but really jumping into a small deployment, because overall lubrication suppliers are trusted advisors for a lot of operators. They look towards the people who have formulated, the people who understand the recommended useful life, and then how those lubricants operate in those applications. It's really important for giving some credibility to the systems that are being installed, and so helps move it past the education phase and the pilot phase to that small deployment phase. And I think lubrication suppliers can play a big part in that. So what are some of the future of oil IoT? How's that improving? How's that moving? If we start from the bottom again, we are continually getting improved sensor technology. So if you're getting better data, it does mean more value creation in the end. So as those sensor technologies improve, we get better data. How can lubrication suppliers help with that? Obviously, improve sensor technology. What's missing? What should be there? The data we are getting in certain aspects, is that good enough? Where could it be better? Really, there's a key place to play in improving what that looks like. Outside of that, we're getting new communication capabilities. 5G is coming in. LoRaWAN is taking off. Wi-Fi 6, which is extremely fast. Wireless is kind of coming on board. So there's new communications that kind of fit the bill a little bit better at a lower cost. Edge computing is improving. So we're actually moving some of the machine learning and AI from the cloud back onto the asset level for faster decision making where it's necessary. The big data lake kind of space is getting much faster. So we're seeing more data sources being able to be stored in the same location, and it just being extremely fast to run analysis off of that and combine that data together. And then up at the higher level, the analytics, again, machine learning and AI is always continuing to improve. They're combining it with MRO data as well, lab data, sensor data, again, and integrating more of that from the big data back into the analytics, and then integration with CMMS systems. So you're, again, having that data kind of flow through, and the analysis that's done back to those doing the maintenance itself helps with that improved process. And so lubrication suppliers can play a huge role in that by providing that better analysis. What does that look like maybe from a little bit more complicated position? What is that kind of system? What could that look like? This is a great example of what we're doing with wear debris. On the left-hand side, that red line is an example of wear debris increasing on an industrial asset over time as that SPAL starts to increase. You can see the peaks are getting higher, meaning we're losing more mass of ferrous material from that failure. What you can see in the green is when we implemented a control change to eliminate the condition that was causing that damage. So we were able to slow down the progression of that fault. So what could feed into that in this new paradigm? So we're doing that part today. What else could we pull into that? Well, there's SCADA operational data from assets. What is it doing? There's digital twins. There's models of that bearing itself. What is it doing? What does it look like? What do the loads during the operation mean that it's doing to the fluid dynamics? So the mixed DHL analysis. Again, lubrication suppliers play a big role into what that would look like. Feeding all that back into an other failure history around that particular type of bearing or asset or whatever it is into the machine learning models can then help identify here's the things that are causing that problem. Lubrication suppliers can play a big role in this, is because what is the solution to fixing that problem isn't always necessarily a mechanical engineering solution. It's not always an electroengineering solution. It's not always some sort of physical change that someone else can do. It really can come down to, is there a different formulation that makes sense? Is there something else that needs to happen to reduce or eliminate the condition that's causing that damage? And we're already doing this today in some form or fashion, but as we implement all the things from the previous slide into this system and then get better feedback from the experts in different areas, this only gets better in our ability to extend the component life, integrating all these kind of different capabilities together through one overall system. And so to end and kind of highlight a little bit here, lubrication suppliers for sure can, key participants in the IoT value chain. Definitely, there's a lot of different areas. The main different ones we've listed here are sensor improvements themselves, lubrication suppliers. You have an insight into what needs monitored for proper lubrication. So feedback to sensor suppliers is extremely critical. If you're feeding back, these are the sort of things we have to know to understand the system better, to predict or identify problems. Having that feedback to the sensor manufacturers is extremely important. If we do have a suite of sensors available, what sensors should we use? Also that same feedback. What does that look like? What formulation is being used that identifies in this particular application? What should we be looking for so that we're using the optimized, the cost-efficient set of sensors as opposed to everything or not enough? Analysis of the data, again, a big piece. If you understand the system, the formulation, the useful life behind it, helping pull value out of the data is extremely important capability and tool to add to the system. Once we've identified those problems, what are the solutions for it? So what should be done to improve the system? It's not always a manufacturer, machine OEM that designed the system. Lubrication suppliers have a piece of the puzzle, and definitely could come up with some solutions to improve that again are more cost efficient. And then overall acceleration of accelerate the adoption overall. So lubrication suppliers, you are trusted advisors. Operators come looking and listening to you what that looks like. So getting past are there sensors out there that make sense, but really moving into, once you're comfortable with the sensors, moving the operators into small deployments so they can see the value and start getting that value back, as opposed to constantly trying to test it and prove it out at each individual end customer. So there's really an efficiency to be gained here, and I think lubricant suppliers play a big role in that. Thank you.